Hey guys, today we are going to go through a whole bunch of geometry vocabulary. So I just want to kind of touch on each little thing, and if you have any questions, make sure you ask. I'm going to go through these kind of quickly. So a point is an exact location with no size or shape. So we represent a point with a point. So like that would be point P, this would be point Q, point R. Okay, so it's just a point, an exact location. A line is made up of points with no thickness or width that goes on forever in both directions. So we usually have a line and it has arrows on both sides to say that it goes on forever. And then typically somewhere along the line we have points that we name so that we can use those points to name the line. So if I was going to name that line, I'd call it AB. And then the symbol I would put over it was the line with the arrow. Okay, so we would call that line AB. A line segment is a part of a line consisting of two endpoints. Okay, so that means that rather than having arrows at both ends, I basically have dots at both ends. So say that's a C and a D. So a line segment are the two letters with just a line segment on top. So no arrows with that one. Okay, so that would be line segment, CD. A ray is similar, but it goes on forever in one direction. So it has a distinct endpoint, and then the other end has an arrow. And we basically would name it the same way. So if I wanted to call that EH, okay, if I had an E and an H on there, I would put EH, and then over that I would draw a line with, or a segment with one arrow. Okay, so that would be ray, EH, that's an A. Okay. A plane is a flat surface made of points that goes forever in all directions. So, we have a plane is a flat surface, right? So this would be a plane. A plane is, any 3 points can be a plane. Okay? You need 2 points to make a line. Can be connected by a line. Any 3 points can be connected by a plane. Okay? So anywhere in there. Collinear. Co means the same, right? So, and linear means line. So, the same line. So, if I go back to my line AB that we had earlier, and say I put another dot on there, say this is F. Okay, so A, B, and F are collinear because they're all on the same line. Okay, coplanar, so a plane, we already said, is a flat surface. So coplanar means same plane. So that means that somewhere on my plane I have points. So this could be C, this could be D, this could be H, this could be J, right? So C, D, H, and J are coplanar. Okay? All right, let's look at some more. So congruent segments, anything that's congruent is the same length. Okay? So in order to show that, we're going to talk about later on measuring. So in order to show that they're the same, we would say this is A and B. And then we also have C and D. We would say segment AB is congruent. So it's equal sign with a squiggly line on top, and CD. Okay, only line segments can be the same length, can be congruent. So the segment addition postulate means that if A, B, and C are collinear, so if I have A, B, and C, if they're collinear, that means that if I take AB and add it to BC, so here's AB, and I add it to BC, then I will get AC. Right? So AB plus BC equals AC. So I can plug in numbers there. So say this is 2 and this is 3. I would have 2 plus 3. And that tells me that the whole segment is 5. The distance formula is used to find the distance between 2 points on a graph. So when we have 2 points, A and B, and they have coordinates, x and y each. So we'll call that x and y, and then we'll call this x, we'll say x2, y2. Call that x1 and y1. To find the distance between those 2 points, the formula is x2 minus x1 squared plus y2 minus y1 squared, and then we take the square root of the whole thing. So basically, we're drawing a little triangle and doing the Pythagorean theorem. We're finding the difference between the y's, which is up and down, and then we're finding the distance between the x's, which back and forth, and we're doing a little Pythagorean theorem there. Our next one is the midpoint formula, and that's where you want to find the point that's exactly in the middle. So here's AB again, and here's the middle. We'll call that M for middle. And if A has coordinates of x1, y1, and B has coordinates of x2, y2, then in order to figure out what this is, we would do x1 plus x2 and divide it by 2. So we're taking the average of the x coordinates, and then we're going to take the average of the y coordinates, divide that by 2, and that is going to give us the coordinates of M. And we're going to do a few calculations with that. The midpoint, as you kind of just looked at, if you have a segment A and B, then the midpoint is whatever point is exactly in the middle. So the key to remember that is this AM has to be congruent to MB, oops, if M is our midpoint. So the midpoint cuts the segment into 2 equal sections. The segment bisector, we're going to learn how to draw those. That is a segment or plane that cuts the segment at its midpoint. So again, if I have A and B, then the segment bisector is going to come through and cut this right in the middle at the midpoint, and it's going to create a perpendicular angle. Okay, so perpendicular, remember, is 90 degrees. Oops, 90 degrees. And that's what makes it a segment bisector. Then we have a circle. Yep. A set of points equidistant from the center. So equidistant means equally distant. So equal distance. So I can't draw a circle very well, but every point around my circle that looks suspiciously like a square is equal from the center. So this segment, the radius, is equal to this segment. So we call that the radius. All right, symmetry, the property of an object that allows us to divide it into 2 identical halves. So anywhere in the triangle or anywhere in a square, so here we have the line of symmetry. We call that the LOS, the line of symmetry. If you have a square or a rectangle, it has multiple lines of symmetry because I can fold it this way or I can fold it that way. And we're going to talk about other shapes that have multiple lines of symmetry also. Perpendicular, we just kind of drew that. The thing to remember, there's a symbol. We're going to use that when we get to proofs. But basically what that means is you have two line segments that form a 90-degree angle. So remember that this little box means 90 degrees. You're going to see that on a lot of drawings. So if this is AB and this is CD, we would say that AB is perpendicular to CD. A perpendicular bisector, I think we just did that. Oh, no, we didn't. Okay. So a perpendicular bisector is something that bisects a line segment right in the middle, and it creates a perpendicular intersection while it's at it. So this can be a line or a ray or whatever. It has to form a 90-degree angle, and it cuts, say this is M, it cuts this into two equal sections or two congruent sections. So AM would be congruent to MB. I think we did say this already. Okay, parallel lines are two lines that never intersect. It has a special symbol too. It looks like two lines just next to each other that never intersect. So if I have A and B and C and D, and these have to be lines, not line segments. I guess they could be line segments. We would say AB is parallel to CD. Then we have angles, the intersection of two rays at an endpoint. So we have an endpoint, we have a ray going off in one direction, we have a ray going off in another direction, and what's left between them is measured in degrees, and that is our angle. So typically we name an angle with three letters. So this we would say is angle ACB, or we might say angle C, depending on what we're looking at. The key thing about the angle is you need to be able to identify the vertex. So the vertex is where it all comes together. Oh, look, that's next. The common endpoint of an angle, there's your vertex. Okay. A right angle is an angle with a measure of 90. So you can see this way, this little box means it's 90 degrees, and that is a right angle. An acute angle is less than 90 degrees. So something like that is less than 90 degrees. An obtuse angle is greater than 90 degrees. So something like that is an obtuse angle. And then we have a straight angle. This is the one you're going to use a lot in this unit. A straight angle can still have a vertex technically, but it makes a straight line. And the big thing here is that they add up to 180. Okay, so if I have a straight line, the measurement for a straight line is 180. You'll see a lot. Congruent angles are angles that have the same measure. So if I have, even if I turn them the other way, say this is 60 and this is also 60, and we call this angle ABC, and we call this DEF. I could say that angle ABC Remember, congruent is equal sign with a squiggly on top. Angle DE. Adjacent angles share a common side. So if I have this angle and then this angle, you see how they share the same side? Right down the middle, or sort of in the middle. So these are adjacent angles. If two angles are adjacent, that means that you can add this measurement plus this measurement and get the measurement of the whole angle. So let's name these. If we call this A, B, C, and C, B, D, we can say that angle A, B, C plus angle C, B, D equals whatever the measurement of A, B, D is. So we've basically just put the two angles together and gotten one big huge angle. An angle bisector is a line or ray that bisects an angle. So bisects, remember, that has to be two equal parts. So if we bisect a segment or we bisect an angle, so if this is our angle that we start with, an angle bisector gives us two equal angles. That doesn't look very equal, but trust me, that's what they're supposed to be. So the big thing, you show equal angles by drawing one little line here and then one little line there. So that tells me that whatever the degrees are, that they're the same for both. What do we have? Vertical angles are formed by intersecting lines. So anytime you have two lines that intersect, you're going to create what are called vertical angles. So what that means is this angle here and this angle here are vertical. They're across from each other, but they're also congruent. So this angle here are also congruent. So I'm going to use two different lines. So for my first set of angles, I just used a little line. For the second set of angles, I use two lines because they're not necessarily equal across this way. They're equal across. So the straight across ones are equal, and the other straight across ones are equal. All right. Complementary angles, they have to add up to 90 degrees. They don't have to be adjacent. So I could draw a 30 degree angle here and a 60 degree angle here. And I would say that together they are complementary. So 30 plus 60 is 90. So they are complementary. Then we have supplementary, which is one that you will see a lot. Two angles that add up to 180. So these are going to be your linear angles. So anytime you have a straight line or two angles that add up to a straight line, so I have this angle, I have this angle over here, that means they're going to add up to 180. So again, they don't necessarily have to be on the same line. I could do a 90 degree angle here and a 90 degree angle over here, and they are supplementary because 90 plus 90 is 180. And then I have supplementary angles. Finally, we have what are called a linear pair. You're going to see this a lot. So a linear pair are supplementary. So I might have this as an angle. And so say this is 30, and then say this is 150. 30 plus 150 is 180. And they make a straight line. So a linear pair do have to be adjacent. So here is the line that they share. So that makes them adjacent. So they are adjacent and linear. We're going to do a lot more practice with this vocabulary, and I know this is very long, but that is pretty much everything we're going to use in this unit. So let me know if you have any questions.